Hi, Algebra 3. We are about halfway through our linear unit, and so you should have in front of you your notes all about inequalities. And so it will look like this. It'll have the inequalities on it, and we're going to be taking a look at number lines, coordinate grids, and systems of inequalities. So a number line, that is just in the x direction. You're going to be working from left to right. I kind of call it the one-dimensional inequality. And remember, inequality are things like greater than, less than, greater than or equal to, or less than or equal to. Inequality literally means not exactly equal to. So we're taking out the equal sign and putting in less than or equal to. And so you're going to see problems that look like this, and it'll say solve each inequality and graph its solution. And so the first thing that you're going to want to do, and I have some steps here. Now, if you have another way to solve this and there's a more algebraic way to solve it, which we can go over in class, that's fine. But here's just some steps to help you. First step is to make it an equation and solve for x, meaning put the equal sign back in. Sometimes it helps us to see that. So I've gone ahead and I've put that back in, and now I'm going to kind of draw on this. Okay, and so we know here that a -3 minus 6 is going to be -9, and so I get 0 equals 3x minus 9. And I'm going to move that 9 to the other side, and I get 9 equals 3x, and so I have x equals 3. Now this is a boundary point, okay? So I know that x equals to 3 is a boundary point, and that is a really important point, which we will we'll take a look at what happens next. We'll see if it's going to allow me to do this. So step 2 is plot that point, okay? Plot the boundary point, and at this point stop. Make sure you know if it's going to be a solid dot or not, and that depends on right here. Because it's greater than and not greater than or equal to, I have an open dot at 3. Notice it's not filled in, it's an open dot at 3. Okay. Okay, once I have my boundary point plotted, I'm going to do step 3. This is where you need to pick a point and plug it into your inequality. And then you're going to ask yourself, is my point a solution? So be nice to yourself. Pick a nice point, like 0. So what I'm going to do here is you go back to the inequality. You can see I rewrote the inequality down there. Then I plugged in 0. Wherever I see x, I'm going to plug in 0. I picked that point. If you want to pick -100, pick -100. I'm going to make my life easy. So pick 0 and then solve. Well, 3 times 0 is 0. Okay, 0 minus 9 is -9. Is 0 greater than -9? Okay, that's the question. Is that true? All right, so then you go to step 4. Step 4 is on your point. If it is a solution, draw your arrow towards that point. Well, 0 is a solution. 0 is greater than -9. So my solution, I'm going to draw my arrow towards 0 because 0 works. And what that means is every number to the left of 3, it doesn't include 3, but every number to the left of 3 is a solution to that inequality. That means we have a lot of solutions. Okay, let's try question 2. So question 2, same thing, same steps. First thing I'm going to do is I'm going to set that equal to, and I'm going to find my boundary point. So 1 plus 1 minus 1 gives me 0, and I end up with x equals -2. I'm not going to do that work on that one. I expect you guys to be able to do that. X will equal -2. Okay, my next step, pick a point. Guess what point I'm going to pick, guys? Yeah, you guessed it. I'm picking 0. So when I plug in 0, I get 4 times 0 is greater than or equal to -8. Okay, so let's see what that looks like. Is 0 greater than or equal to -8? Is that true? All right, so let's put in our point. My boundary point is -2, And because it's equal to, I fill it in. Okay, so that means my boundary point is a part of the solution. Now, is 0 greater than or equal to 8? Nope. So I have to draw my arrow to the left. I'm drawing it away from 0 because it's not true. 0 was not a solution. So my arrow has to point away from it. Okay, let's have you guys try a few. Oh, hang on. Let me clear all my drawings here. Okay, for you, now in your notes, you should see number 3 and number 4. You need to pause the video here and see what solutions you get. Go through the 4 steps, take your time, and then come back and check. All right, welcome back. You were given the task of trying 3 and 4 on your own. Let's see if you got them right. Okay, the solutions should look like that. You should have a filled in dot at 0 pointing to the right for number 3, and number 4, it's an open circle at -3 pointing to the left. Okay. If you didn't get those correct and you're still confused, come see me or Mr. Hogsett. All right, but really, guys, what we're going to be looking at is we have so much more to do than just one-dimensional or just on the x-axis. We have the coordinate grid 1 inequality, okay? So let's take a look. You should have your notes open to the coordinate grid, and we're just going to look at one inequality, which is y is greater than 2/5 x plus 3. Okay, so step 1, make your inequality look like y equals mx plus b. So there it is. It's right down there. I accidentally forgot to close off step 4, so you're just looking at step 4. But right underneath step 4, you can see I took out the greater than sign and just put y equals 2/5 x plus 3. Okay, graph it. You guys all know how to graph, so let's go back and graph. My y-intercept is at 3, and my slope is up 2 to the right 5. Okay, or I can go down 2 to the left 5. And there is my line. So again, is it a solid line or is it a dashed line? Well, it's going to be a dashed line, guys, because there's no equals to. So it just means that I can't, the line is not a solution. Okay, so here's my line. Now, unfortunately, I don't think I can dash this guy. So, yeah, you're going to have to pretend it's dashed, but it's a dashed line. So there's step 2. I just graphed that line, y equals 2/5 x plus 3. So step 3, it is just like the before. Okay, go back to the inequality and pick a point on the graph. But now it's a coordinate grid, so now you have to deal with x and y. So I go back to the inequality. I just wrote it. Y is greater than 2/5 x plus 3. Guess what point I'm going to pick? Yeah, I'm going to tell you, be nice on yourself. Pick 0, 0. So that means y is 0 and x is 0. So it looks something like that. So I plugged in 0, 0, and now I solve. Okay. Is 0 greater than 3? Well, step 4 says, if your point's a solution, shade toward the point. If not, shade away. So again, is 0 greater than 3? No. So that means I have to shade, and I'm going to do this guy, I have to shade away from 0, which means everything that I am shading, you can pick any point in the region that I'm shading. Try it. Pick a random point anywhere in this shaded region, and it will make the inequality true. Okay? Anywhere in that shaded region is a correct answer. If it's not in the shaded region, it's not going to work. So let's see. There it is. You can see that that's the official line. It's dashed. That's what the solution looks like. Okay. I'm going to clear all of these off. And guess what? It's time for you to try one. So stop the video here and see if you can do number 2 on your own. Welcome back. Hopefully you tried that one on your own. And this is what the solution looks like. You have the line y equals negative 6x plus 2. It's a solid line, and you were to shade everything to the left of that line. Okay. Again, if you didn't get that answer, come to class with that question, and we will work that. But here's where we really want to be. Okay, our X and our coordinate systems, they're great, but for the next lesson, when we do what's called linear programming, you have to know it's a system of inequalities. Now, the word system means that you now have two or more lines on the same grid. So your problem now will include two or more lines. So let's try this one. We have two equations. Now again, step one is going to be graph. So let's graph. Let me get this out here. So step one, I have y equals 3. I love that one. I'm going to do this one first. So I'll circle that. That's the one I'm going to do first. The reason I'm going to do that is because I know my y-intercept is 3 and my slope, remember, I could write this like this. I could be writing it like this, 0x plus 3, which means I have a slope with a 0 slope, which means I have a horizontal line. Okay, which is really nice. So here is my line. It is a solid line, so thank goodness I can draw that as a solid line. So there's my first line. Okay, well, I'm going to change to blue here. And we're going to look at blue. So let's take a look at that next inequality. And I'm going to just write it y equals 2/3 x plus 1. Okay, so remember, take the inequality out, don't worry about it, and let's just plot this one. So this one means I have a y-intercept at 1, and my slope is up to the right 3, or I could go down to the right 3. Okay, that's what that means, up to the right 3. Okay, so now I'm going to draw a line here. Kind of have to eyeball this a little bit. And when you draw your lines, make sure you get all the way through. Okay, but now I have to check both of these. I just drew my lines, but now I have to check. So let's go back to this guy. Okay, so, oops, let me draw here. So now I have y is greater than or equal to 3. You know what one I'm going to put in. I'm going to put in 0 for my point, and I get this. Y is greater than or equal to 3. True? That's a question mark. Yeah, no, 0 is not greater than 3. So I'm going to shade all of this area red. Okay, don't focus on the blue, just focus on the red. Everything I shade here is a solution. I have to shade away from 0, 0 because 0, 0 did not work. It's not a solution. Everything above this red line, pick one, try it. It's a solution. Okay, let's go to the next one. Where are you, blue? Okay, so now I'm going to rewrite this. I had y is greater than or equal to 2/3 x plus 1. Pick 0, 0. Make life easy on yourself. I get 0 is greater than or equal to 2/3 times 0 plus 1. Well, this guy just goes away because 0 times anything is 0, and 0 plus 1, so you get this. 0 is greater than or equal to 1. Again, question mark. Is that true? Well, no, it is not. 0 is not greater than 1, so I have to shade away. So I'm going to shade everything above this line. Ooh, I'm getting a little crazy with my line here, guys. Okay, here we go. I'm going to shade all of this blue. And all of this blue. So you get everything kind of up and to the left of that blue line is a solution to the blue line. But the question is where are the solutions to both lines? Well, do you see where the red and blue mix, where those two colors combine? Where the two colors combine, that's the solution to both. And so here's what the real solution set looks like. And I'm going to try to do this in black. And notice we're going to cut off a chunk of the red, and we're going to cut off a big chunk of the blue. And that is your final answer. Everything I'm shading in black is a solution to both of those inequalities. I don't want the solution to just one. We need the solution to both. All right, so that looks kind of messy, guys, and I know it does. But here is what your solution should look like. Okay, that's, if you look down in that right corner there, that is the solution. And it's a lot prettier, but I wanted to show you where those two colors blend. That's the solution to both of them. Okay, you guys definitely know by now where we're headed with this. You get to try one on your own. Please stop the video here and try number 4. You have two equations, graph them, find the solution, the area for each one. Use colored pencils if you have to and find where those colors blend. Okay, good luck. All right, welcome back. Check your work. If you got that, excellent. If you did not get that, please bring this up in class. You're going to have to do a few in class anyway. Let's bring this one up and we'll use it as an example. Okay, go try, I think it's daily practice. Oh, I'm not sure, I can't remember. 7, I think. It's the next one, it's the one under this video. Thank you, Algebra 3, and have a great day.